Greetings to all. In today's session, we are going to discuss about the intermediate chemistry, which is very important for international any chemistry entrance examinations or competitive exams. In India level, JEE Advanced, JEE Mains examination, NEET Chemistry, and also Telangana EAMCET, AP EAMCET examinations, any other competitive exams the uh, people are aspiring for. For all these sessions, this kind of explanation will be very much helpful. These are the topics which are collected from the previous year question papers, and the detailed explanation is provided here. For sure, I will assure that this session will be helpful for the entrance and the competitive exam as well. Let's go with the question number 1. The most electronegative of the following element. So, electronegative element we have to find out. The options provided are sodium, bromine, oxygen, and fluorine. These are the these are the elements which are collected from the periodic table, and we need to identify which is the highest electronegative element among all, right? Electronegativity of any element can be measured based on the Mulliken scale. So, according to Mulliken, electronegativity is calculated by taking ionization enthalpy plus electron affinity by 2. This will be the formula in order to calculate ionization enthalpy plus electron affinity by 2 is the formula for the calculation of what electronegativity in accordance with the Mulliken, right? According to this, there is a gradual decrease in the trend of electronegativity from top to bottom. As we are descending from top to bottom, gradual decrease in the electronegativity we can notice. For example, if you observe hydrogen, lithium, sodium, potassium, rubidium, cesium, and francium, francium is more electropositive, rather least electronegative element. Lowest electronegativity will be noticed for the elements which is in the extreme left corner, left bottom corner, and moreover, the element which is in the period. If we observe the elements of period moving from left to right, as we are ascending towards the right side, electronegativity will be gradually increases, right? Electronegativity values are increasing, so that fluorine is the atom with the highest electronegativity in the entire periodic table, and the francium is the atom with the lowest electronegativity. So, based on this, here it's very clear that most electronegative is fluorine. The right answer for this question number 1 will be option number 4. Let's move on to question number 2. The purest form of iron is. This is the question given from metallurgical process. Here, iron can be extracted from various kind of minerals, and various ores will be there for iron, hematite, magnetite. So many compounds will be there, and from which we can extract the iron. So during the extraction, so many different samples of iron will be produced, called wrought iron, steel, pig iron, nickel iron or nickel steel will be there. Among all, we need to identify which will be the purest form of iron. Purest form of iron is nothing but highest quantity of iron and the lowest quantity of other ingredients will be there. That is called a purest one, right? So in order to get this, let's see one by one. Wrought iron. Wrought iron is the pure form of iron and contains only 0.5% of additives. Remaining 99.5% of iron will be there. Hence, we can say it is the purest one. So, wrought iron is with only 0.5% of impurities over there. And next is about cast iron. Cast iron is also known as a steel, where 2.5 to 5% carbon will be added. So whenever carbon is added over here, what happens? Its strength is tremendously increased, so that steel always having the blend of 2.5 to 5% of carbon, right? This extent is there, so that we can't say it is the a pure one. And next is about pig iron. Pig iron is containing high carbon content. Carbon quantity is the measure of its strength, right? Where 3.8 to 4.7 percentage of carbon is present, that is said to be a pig iron. And the stainless steel is another compound where you can notice the mixture of chromium and nickel over there. So that 4 to 8% nickel content will be there. Among all, lowest percentage of impurity addition we can notice, that is only 0.5 percentage of other additives are there apart from 99.5 percentage of iron, that is the wrought iron. Hence, purest form of iron is wrought iron only. This is for question number 2. Option number 1 is the correct answer. Let's move on to question number 3. For diatomic molecules, the correct statements we need to notice. Here, diatomic molecules, molecular orbitals are taken into the consideration. Overlap of two 2pz orbitals are possible. 2pz orbital overlap is possible in two ways. One is called axial overlapping. Second is called lateral overlapping. Axial overlapping gives rise to bonding, anti-bonding. Lateral overlapping also giving bonding, anti-bonding orbitals. In this, what are the correct options we need to identify, right? Sigma orbital having total 2 nodal planes. Sigma star orbitals are having one node on XZ plane containing the molecular axis. Pi orbital have one node in the plane which perpendicular to the molecular axis goes through the center of the molecule. Pi star orbitals has one node in the XY plane containing the molecular axis. Right. So from these 4 we need to predict. B, C options are correct answers among all the given answers. Let's see how it is possible. Right. If you see that sigma bonding orbitals are not having any nodal planes. Nodal planes means where the probability of finding the electrons are 0. That is called a node. Where electron count is 0. Electron density is 0 called nodal plane. For sigma bonding, nodal planes are 0. But they mentioned sigma orbital have 2 nodal planes. This is a wrong assumption. And sigma anti-bonding is having 1 nodal plane. Sigma anti-bonding is having 1 nodal plane is the correct answer. B will be the right answer only. Pi orbital have 1 nodal plane. Pi orbital. Pi bonding orbital is having 1 nodal plane. Okay, this is the horizontal plane. You can notice above and below molecular orbital lobes will be there. Where pi anti-bonding orbitals are having one vertical node, one horizontal node. 2 nodal planes you can notice for pi anti-bonding molecular orbital. So pi anti-bonding is having pi orbital having 1 nodal plane is the correct. Pi star having 1 nodal plane is the wrong answer. D is wrong, A is wrong. Only the correct options are B and C. Sigma star nothing but sigma anti-bonding is having 1 nodal plane. Then pi orbital 1 nodal plane. These two, B, C are the correct answers. Right? For question number 3, B and C are the correct answers. Let's move on to the next one, question number 4. The correct options related to adsorption process is R. More than one answer might be correct also. Right? Adsorption is the branch of physical chemistry where it is a part of adsorption in surface chemistry. Right? Adsorption is the phenomenon purely restricted to the surface rather than interface. Right? Here you can clearly notice adsorption will be restricted to the surface region. The particles are not entering inside, but absorption could experience the particles on surface and even in the interface as well. Right? So that adsorption is only surface chemistry. Absorption is the bulk chemistry. Right? So here, in that adsorption again we can categorize chemisorption, physisorption. If the chemical reaction carried between the adsorbent called chemisorption, only physically that's are adsorbed on the surface called physisorption. Chemisorption is a unilayer process. Yes, it is. Chemisorption will be possible on the particular active sites. Wherever active site is there, there only this adsorbing compound will come and join and fix over there. And moreover, always one layer adsorption we can clearly notice in the chemisorption process. Unilayered is the right answer. Whereas physisorption can be possible more than one layer. adsorbent and adsorbate. Adsorbent is the base or platform on which adsorbate molecules got accumulated in more than one layer, multi-layered process it is. So chemis option is a unilayered is the right answer. Enthalpy change during the physis option is 100 to 140 kilojoules per mole. If you see enthalpy during the physical adsorption, 20 to 40 kilojoules are there. During the chemical adsorption, 40 to 400 will be there, right? So physis option is up to 40 kilojoules, means a lower temperature. This is not the one can be operated at higher temperature, so that we can cancel this. Enthalpy change of phases option is 100 to 140 is the wrong answer. It is the chemis option. And let's move on to C. Chemisorption is an endothermic process. Endothermic means absorbing the heat. So if heat is absorbed, that is called endothermic. If heat is evolved, is called exothermic reaction. If you see this here, during the chemisorption process, 40 to 400 kilojoules heat evolved. So we can say it is the kind of exothermic. Exothermic means releasing out the heat, but not endothermic process, right? So this is option number C is the option number C is the wrong one only. And D, lowering the temperature favors physis option process. If temperature lowers, physis option is possible. That is a correct only, because physis option favorable at 20 to 40 only. So that we can say low temperatures are highly favorable for physis option process. So A is the right answer, B is the wrong answer, C is also wrong, D is the right answer. A, D are right options for adsorption process, right? Let's move on to question number 5. In question number 5, the process in which colloids, when subjected to direct current electrical field, move towards an electrode is. The process in which colloids, when subjected to DC electrical current, move towards an electrode. Okay, here colloids are having some distinctive properties which are extensively studied by various scientists, and they could be Brownian moment, Indal effect, peptidization, electrophoresis. All these are the characteristics of colloidal solutions. Colloidal solutions are intermediate sized particles which lays in between true solution and suspension solution. Brownian, let's move on to one by one. We will discuss all four options which I were provided. Among all four options provided, moving towards electrode is the process called electrophoresis. Electrophoresis is regarded as the correct answer for the question number 5. Although we will go with all kind of options provided in brief. What is the Brownian moment? Whenever colloidal sized particles are in a free movement, so all the particles are having random motion. They are moving in all possible available directions, which is called a zigzag motion. You can notice all the arrows are moving in all possible directions. So that zigzag movement of colloidal particles is said to be a Brownian moment. The scientists who observed this kind of movement under ultra microscope, so that we can say this is the Brownian moment. In either called a Tyndall effect, purely it is the optical property where scattering of light is the distinctive property of a colloidal particles. Whenever you are passing the torch light through the true solution and also through the colloidal solution. Colloidal solution effectively used to show the path of light through which it is passing. But when this torchlight is passing through the true solution, we can't notice from where light is moving, from where light is passing. But it is clearly visible in a colloidal solution what will be the path of light. Path of the light becomes visible in a colloidal solution, that purely because of the property called scattering of light. The best example in the nature, we can notice the dirt particles whenever sunlight is entering into the dark room. Light rays can visualize the dirt particles because of the scattering of light, which is called the Tyndall effect. That is because dirt particles are the colloidal particles and scattered light is visible, so that we can see dirt particles in the presence of sunlight, though which are very tenuous. And another property called peptization. Peptization is the reverse to the colloid formation, where already existing peptization is the process our precipitate is converted into colloid particles. Okay, so initially the particle size is very large, which is precipitate, which is the highest diameter sized particles. By means of chemical treatment, the particles got converted into colloidal sized particles. We are synthesizing the colloidal particles by means of the process called the peptization, right? Suspension are precipitate particles converted into the particles of colloidal sized by means of chemical treatment is called a peptization, right? Peptization is the process of passing precipitate into the colloidal particles and adding suitable electrolyte. The electrolyte added is called peptizing agent. For example, ferric hydroxide is purely solid, can be precipitated. Whenever ferric chloride is the electrolyte added over here, what it will do? It used to concise the size of ferric hydroxide, and moreover, these iron are able to generate the positive charge over there, so that now the particles are concise to. If you see the diameter, particle size is confined to the colloidal sized particles only. So initially precipitate, finally colloid. The process is peptization. This is also the not part of the question what they are asking for. Let's move on to actual answer what it will be. Whenever electrophoresis is there, two electrodes will be inserted of opposite charges, can be connected to the external power supply. Whenever both are connected to external power supply, whatever cations there moving towards cathode, anions are moving towards anode. That is the process carried in the colloidal solution. This is clearly depicting that colloidal solutions are accompanied by the charges. This is the very essential observation carried by electrophoresis, that colloidal particles are charged particles, either that may accompanied with the positive or negative, but charged particles will be there. For example, if ferric oxide is baptized with ferric chloride, that will be the positively charged chloride, right? So this is the way. So whenever electrophoresis is carried in the U-shaped tube, in this U-tube, we are inserting two electrodes regarded as anode and cathode, and colloidal solution is poured up to the limit over here. Due to the charges present in the colloidal solution, they used to travel in particular direction, and they used to accumulate. Being here colloidal solution taken is negatively charged, you can notice all the colloidal charged particles are accompanied by the negative charges, so that they definitely moving towards the opposite charge like a positive, and they will accumulate it over the cathode. This is the way we can observe passing of electrical current, and the colloidal solution will move towards the electrode, the process called electrophoresis. By applying the current, being colloid as a charged particle is able to deposit at the opposite electrode, the process called electrophoresis. By this, we can notice two advantages. One is separation of colloidal mixture is possible. Positive colloids deposited at one electrode, negative colloids deposited at another electrode. That is one advantage. And second is what charge the colloid is having. That also we can identify by means of this electrophoresis process. This is the question number 5. Option number 4 is the correct answer. Let's move on to last question of the session. The correct order of enthalpy of vaporization of noble gases is noble gases, enthalpy of vaporization. Vaporization is nothing, enthalpy is nothing but amount of heat required. Vaporization is nothing but conversion of liquid into gas, right? So how extent we need the heat in order to convert liquid noble gas into the gaseous noble gas, right? So that order we need to depict over here. The right order will be xenon will be higher, krypton will be next level, argon will be next level, neon and helium tiniest one having lowest enthalpy of vaporization. So let's see how can we justify this answer. by taking the view of the relation enthalpy of vaporization directly proportional to van der Waals forces, right? Greater the van der Waals forces, greater the enthalpy of vaporization. Greater van der Waals forces are accompanied by greater molar mass or atomic mass. If you see, helium is accompanied by atomic mass of 4, neon with the 20, argon with the 39, krypton 83, xenon 131, radon with the triple 2. 222 is the atomic mass units, right? So as we are descending from helium to xenon, what happens? Their molar mass gradually increases. Subsequently, van der Waals forces also increased. That's the reason why their extent of heat required to vaporize them also increases. Hence, the right order will be xenon, krypton, argon, neon, and helium. Enthalpy of vaporization is clearly defined over here. Enthalpy change required to completely change state of one mole of substance between the liquid and gaseous. In order to convert liquid compound into the gaseous one of one mole substance, the extent of energy, extent of heat required is said to be its enthalpy of vaporization. So here the compound, the central principle involved here is how can we change the phase of the matter in accordance with their atomic masses. Greater the size, greater the amount of energy required to change its phase from liquid to vapor. Energy required to transform the given quantity of substance from the liquid to gas at a given pressure. How much energy we need? Usually, it is almost enthalpy of vaporization near to their boiling point values, right? So, boiling point nothing but liquid to vaporization. Enthalpy of vaporization also liquid to vaporization, right? So that we can synonymously say enthalpy of vaporization is nothing but boiling point of that particular substance, right? Here you can see helium boiling point is 4.2, neon boils at 27 and argon at 87 Kelvin, krypton 120 Kelvin, xenon 165 Kelvin, radon will boil at 211 Kelvin. These are the subsequent enthalpy of vaporization values. You can clearly observe highest enthalpy of vaporization for radon, followed by xenon, followed by krypton, argon, neon, and the tiniest helium of lowest boiling point in Kelvin scale, right? So this is the way we can answer, and the right order will be option number 1. For question number 6, option number 1 will be the right answer. By this, we completed today's session. Hope this must be helpful for your preparation, and I am requesting you to kindly share, comment, like, and subscribe this channel. And thank you very much for your patience listening. Thank you one and all.